Hi guys, welcome to our first video on Unit 3 where we're studying the atom. Let's talk a little bit about what an atom is. Well, atoms are essentially the building block of matter, okay? They make up matter. And so that's really where our study in chemistry is going to start. The 2 units prior to this are really more like learning the procedure of how do you measure things and how do you have accuracy and precision in your measurement. But now we're really digging into the roots of chemistry, which is atoms. So we're going to learn about atoms this unit. So an atom, a good picture of an atom I put on the board for you. Go ahead and draw that on your paper. This is our kind of like our modern picture of the atom. There's actually a more modern view we hold right now, but we'll learn about that next unit. This unit, we're just going to stick with this model right now. It works for us right now. As you can see, there's 2 basic parts of an atom. There's the electrons. They're floating around outside on these little, they look like orbits. And then we have this center part of our atom, which is called the nucleus, and it's made up of protons and electrons. So our modern view of the atom is made up of 5 things. So go ahead and write these 5 things on your notes. The first item that we believe is that every atom is divisible. It can be divided. Basically, an atom is not one little BB gun pellet. It is a complex system. It's made of 3 things: protons, neutrons, and electrons. And actually, protons, neutrons, and electrons are made of even smaller things, but we don't worry about that because this is high school chemistry and nobody cares about quarks, okay? So number 2, electrons. What do we know about them? We know they're located outside the nucleus. We know they're basically weightless and they have a negative charge. What do we know about the nucleus? Well, the nucleus is made of protons, which are positively charged. That's really easy to remember because they both start with P. And then neutrons are also in the nucleus, but they have no charge. They're neutral, which is why they're called neutrons. Surprise, surprise. The nucleus itself is very small. In the picture, it looks like it takes up a lot of space, but the nucleus is really just like a golf ball, and the electrons are really like the last seat in the Alamodome, okay? So like the nucleus is super tiny compared to where the electrons are, but it would be super lame if we had a picture that looked like that because you wouldn't see anything. So we draw the nucleus huge, but it's really, 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 really small. And it's dense. All of the mass of the atom is inside of the nucleus. That would be something I would write down on your notes. That's why I'm emphasizing it a couple times. All the mass of the nucleus, all the mass of the atom is found in the nucleus, mainly because protons and neutrons have a lot of weight. And so they are only found together in a really small area, so it's super dense. That also has a strong positive charge because the protons are positive, and so they constantly are pulling electrons around their nucleus. That's why electrons don't just fly off. They're actually kind of attracted to the nucleus. So last thing, or actually there's 2 more things we know about the atom. 1, not every atom of the same element weighs the same. For example, not all hydrogen atoms are exactly the same. All hydrogen atoms have a few things in common. For example, all hydrogen atoms have the same number of protons, but they do different other things. They have different numbers of neutrons, which kind of gives them a different mass. You don't have to necessarily know that now. What you need to know is that not every atom of the element weighs the same, okay? So all hydrogen atoms are not exactly identical. All carbon atoms are not all exactly identical. They have slight changes. Kind of like how twins have the same DNA, but they're not exactly identical all the time. Number 5 is that atoms can't be destroyed, and that's not 100% true, but kind of true. Okay, so, well, let me go back. So these are 5 things we believe about the atom. In this video, our primary purpose is to know basically how did we come to know these things about the atom? Who discovered these things that we now believe? So we're going to start way back in the day with this guy called Democritus. Democritus is a really old dude. He lived about 2,400 years ago, and he basically came up with the idea of the atom. Remember, back in this time, in this day, they don't ever experiment. They just thought through everything, and if it made sense in their head, it was fact. Not super reliable, but whatever. Basically, he said, if I cut an apple in half, and then I cut it in half again, and then I cut it in half again, and again, and again, and again, and again, and again, eventually, I'm going to get to a tiny little particle I can't cut anymore, right? It's too small, I can't cut it. He said the particle you can't cut is an atom. A loose definition that we now know is wrong, but that's what he thought. This piece can't be cut, so he named it, dun 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 dun, atomos. Atomos means can't be cut, okay? Now we call it the atom, but he titled it atomos. So I call this the BB gun pellet theory. He thought atoms were super tiny, you can't cut them, like basically hard little spheres that you can't cut. So anyway, that's what he thought. Dalton comes along 2,400 years later, and we're now learning something about the atom. Dalton comes along. He still thinks this is right, which it's not, but whatever. He still thinks in the idea of atomos. So he comes up with 4 postulates. Let me write that word out. A postulate is basically an idea, a theory. These are his 4 postulates about, about atoms. Number 1, matter is composed of indivisible, that means you can't cut it, particles. This is the atomos thought, okay? He basically stole this idea from Democritus. Plagiarism. He should have quoted him. Number 2, he said that all atoms of an element are identical. He said all hydrogens are the same. All carbons are the same. All phosphoruses are the same. Number 3, he said all atoms of different elements are different, which is implied from his number 2 postulate, right? If all atoms of the same element are the same, then all atoms of different elements are different. So anyway, those are 2 thoughts he had. And the 4th thought he had was in a chemical reaction, atoms are rearranged to form new compounds. They are not created, destroyed, or changed into atoms of any other elements. Here's a picture of basically what he's talking about, okay? So here you have 4 hydrogens and a carbon. Here you have 2 oxygens, and he says atoms can only be broken from their molecule and rearranged. So he says, okay, we haven't lost anything. Like we still have the 4 hydrogens from before. We still have the 1 carbon from before. They just rearranged. Okay, so now let's talk through his idea. By the way, John Dalton was 1766 to 1844. So a long time after Democritus. Again, dates are not important. What were Dalton's problems? This is on the test. Please make sure you write this down. The first thing he came up with is wrong. Atoms are not tiny little BB guns. They can be divided, right? They can be divided into what 3 things? Protons, neutrons, and electrons, right? So he got that wrong, which means Democritus also got that wrong. That's why you don't plagiarize, people. Okay, number 2. He said atoms of a particular element are identical. Also wrong, because of isotopes, which we'll talk about later in another video called isotopes. But basically all you need to know is that atoms of the same element, so like all hydrogen atoms, they're not exactly the same. Remember, they slightly differ in their masses. All of it, anything I'm saying right now should be on your notes. So atoms of a particular element are all identical. Dalton got that wrong because atoms of the same element have different masses. Okay, his 3rd and 4th things were both basically right. Atoms of different elements are different, and in a chemical reaction, atoms rearrange. The only difference is that we can change an atom into another atom in a nuclear reaction, which we'll learn later, so get excited about that. But basically, we're going to say that these 2 he got right, and these 2 he got wrong. You will need to know which ones he got wrong. Okay, so let's recap. He said atoms cannot be divided, and we say they can. Well, how did we discover that atoms could be divided? Thanks to this guy in 1897, not too long after Dalton, called J.J. Thompson, who J.J. Watt is actually named after. You can see the resemblance, can't you? They look stunningly identical. J.J. Thompson came up, I almost said J.J. Watt. J.J. Thompson came up with the cathode ray experiment. Write that down or highlight that. The cathode ray experiment, that's a term that you will have to know on a test. The cathode ray experiment basically worked like this. He stuck a neutral gas in a tube and closed it off. Do you guys know what neutral means? So you can have something that's positively charged or negatively charged or not charged at all. Something that's not charged at all is called neutral. Okay. So he took this neutral gas and he kind of stuck it into a tube, And then he ran electricity through it. This is my electricity line, okay? When you run electricity through things, I don't know if you totally know how that works, but basically what happens when you run electricity is that electrons kind of can pop off of atoms, and that's kind of what forms the electric current. So when he ran electric current through it, the neutral gas became charged because it was popping off electrons. It became negatively charged just for a little bit. This is why the discovery happened, he put a magnet on either side. He put a positive magnet at the top and a negative magnet at the bottom. Can you guess what the gas started to do? If the gas got temporarily negative, the gas was kind of flowing through. It made a line towards the positive magnet. See how it's bending towards the positive magnet? That's because there were electrons, right, that kind of popped off and got curved towards the positive charge. So here is what Thompson observed. The current passed through the gas curved towards the positive magnet. He concluded that an atom, if the gas is curving towards the positive, the atoms must be negative, right? They must have a negative part. So here's what he discovered. He said there are negative particles inside the atom, which means the atom was divisible, right? If there's a smaller part inside of an atom, that means the atom's made of parts. It's divisible. He called them corpuscles, which is like the worst name I've ever heard, which is why we did not keep it, and we changed the name to electrons. So Thompson basically discovered electrons. But Thompson's a smart dude. So he concluded something crazy. He said, whoa. Everyone hold your horses and stop the carriages. This atom is a neutral atom. It's a neutral gas. And yet, it's got a negative part to it. How did that happen? If this is a neutral atom, its charge is 0. Like, it's not positive, it's not negative. And it has a part that's negative to it. Well, in order for it to still be neutral, it would also need a part that's, you guessed it, positive. He basically said, I am seeing the negative part of the atom, but I know the atom's neutral. That means there's got to be a positive part of the atom that I'm not seeing. Okay, so he never actually found that positive particle. He never found it, but he did guess that there was a positive part to the atom, and he was right. So here's the picture he came up with. It's not that impressive, actually. He said the atom looks like this. Instead of a small, tiny little BB gun pellet, he said it looks like plum pudding, which nobody knows what that is because it's kind of an English thing and it's kind of disgusting. It's basically bread, soggy bread with raisins in it, okay? He said the raisins are like electrons and they're evenly spread out. And he said this positive substance that he never discovered is like this yellow part. It's the bread that surrounds the raisins. That's called the plum pudding model. Well, obviously we know an atom doesn't look like that, right? We know it has the nucleus with the electrons outside. Question, how did we get to learn that the plum pudding model was totally wrong? And how did we get to our current idea of the atom? Well, we can all give thanks to this guy named Ernest Rutherford, who was born in 1911 and was a stellar scientist and someone I have a humongous crush on, even though he's dead, which I know is weird. I'm just saying, if I was born in 1911, I might be married to someone else. Just saying. Ernest Rutherford's awesome. In fact, he even has an atom named after him called Rutherfordium. How cool do you have to be to have an atom named after you? Pretty cool. So here's what Ernest did, okay? I call him Ernest because, you know, we're like close. So he said, I'm going to do this cool experiment. And he said it like that because he's kind of like a bro. He's like, I'm going to do this cool experiment, okay? I'm going to take this laser because, you know, guys and lasers, and he shoots this laser, which is positively charged. It's really strong laser, positively charged. I'm going to shoot it at gold and see what happens. Yeah. Let's look at the plum pudding model and see what he thought was going to happen. So this is what he thought an atom looked like, right? J.J. Thompson told him that an atom, everything is evenly spread out. He said electrons are evenly spread out. The positive unknown substance that no one knows about is evenly spread out also. And everything's just even, just like a roll of dough, okay? And remember, positive charges have mass, right? They're heavy. But if they're all evenly spread out, then they're not that heavy. It's not that dense. So that's what he thought he was shooting at. He thought he was shooting at this like thin thing of dough where like everything's spread out. And so he shoots these are his rays, by the way, that he's shooting. He shoots these strong positive rays through it. And he just thinks it's going to go straight through. Like if I had a gun, which I don't, and I had a piece of tissue paper, which I also don't have, and I decided to shoot it through the tissue paper, which would not be a good idea, I would just imagine the bullet to go straight through the tissue paper, right? Well, that's not what happened, guys. This is what happened. He took his laser, which he was super excited about, and he shot it through the gold foil, and something crazy happened. Most of the rays, this is important, write it down. Most of the rays went straight through. That's most of the rays. They went all the way through the gold, just like he expected. But a few of the rays were rebels, and they shot straight back at him. A few rays, we call it deflected. Deflected means when you hit something, you just go the opposite direction. Go back where you came from, like a boomerang. So this one greatly deflected. This ray slightly deflected. He thought all the rays would go straight through. It's kind of like, here's basically what happened. It's like if I had a BB gun, and I was, not a BB gun, what do you call the gun that like shoots a bunch of bullets right after another? Like a bullet? No, collie. I don't know what it's called. Like whatever that gun's called. Okay, if I took one of those guns, shooting at tissue paper, and one of the bullets didn't go through, but came back and hit me, like, first of all, I'd be dead, but second of all, I'd be like, what the heck happened? Like, all the bullets are supposed to go through. The reason why, well, I'm getting ahead of myself because this is so exciting. Let's talk through it. This is what Ruth Rutherford saw. Most of the rays went straight through, but a few were greatly repelled. Write that down. It's important. That's weird because he thought the atom was evenly spread out. Apparently, the atom's not evenly spread out. Since most of the rays went through, he theorized that most of the atom was, this is super important, most of the atom is empty, which is true. Most of the atom is empty space with some electrons. But remember, electrons don't have mass. So most of the atom is just massless negative electrons, okay? Since a few rays were greatly deflected, it means they must have hit something very dense and positive. Because remember, he's shooting a positive ray. So the only way the positive ray would come back at him is if that positive ray hit something else that was positive, okay? So he's like, oh wow, I hit something. That means in an atom, there must be something that's really, really massive and really, really positive. Remember, he thought everything was evenly spread out? We now know that's not true. The atoms, the protons and the neutrons, they're not spread out. Protons and neutrons form a nucleus that's a strong, dense, positive ball, okay? All of them are in the same place. So if that ray went right over, it would go straight through. Let me show it this way. If the ray went straight over the nucleus, it was fine. But when that ray hit a nucleus of a gold atom, bam, it got shot back. Remember, he thought it was even, so all the rays would go through, but it's not even. It's super dense. So it hit it and came back. So since only a few of the rays hit it, we know the nucleus has to be small. If a bunch of the rays came back, we would know the nucleus was huge, but it was very small because only a few of the rays hit it. So he said the nucleus is positive, it's super small, and it's super dense. These three things you will be tested on. Please make sure you write them down. The nucleus is small, the nucleus is positive, the nucleus is dense. The rest of the atom is, right, empty space with some electrons. This is his current view now. Small, dense nucleus that's positive. Electrons on the outside. That's Rutherford's model, which is very close to what our model is today. And these are the things that he discovered. Make sure you write them down. That's it for our 3.1 video. Y'all have a wonderful day and dream of Rutherford. Bye.